You're listening to Weekly AI News with Shaylee. What if the secret to building superintelligence isn't training a bigger model, but simply letting a smaller model think before it answers? This week, I kept coming back to one number: 7 billion. Now, in the world of AI, 7 billion parameters is small. It's a lightweight. It's the kind of model you can run on a high end laptop. But a mathematical breakthrough just proved that a 7 billion parameter model can beat $100 million AI giants using a tiny fraction of the energy. And it does this just by scaling the AI's thought process at the moment of search. We are seeing a fundamental shift in the physics of intelligence. While the headlines are shouting about billion-dollar clusters, the real story, the one that will actually change how you work on Monday, is happening in the silence between the prompt and the response. Today we're looking at 1. The death of the brute force era. 2. The regulatory hammer falling in Europe. 3. Why the next great AI isn't going to be a giant in a data center, but a reasoner in your pocket. I want to start with the paper that hit our archive on July 8th. It's titled System to Scaling, and I'll be honest, when I first read the methodology section, I had to stop and reread it twice just to make sure I wasn't misinterpreting the efficiency gains. For years, the industry has operated on a more is more philosophy: more data, more GPUs, more parameters. But researchers from Stanford and Google DeepMind just proved that scaling what we call test time compute, essentially giving a model more time to check its own work, outperforms scaling the size of the model by up to 4 times on complex reasoning tasks. Think of it like this. Imagine you have two students. One has read every book in the library, but answers every question instantly, without thinking. That's our current giant models. The second student has only read a few hundred books. But when you ask them a hard math problem, they take a piece of paper, they sketch out 3 different ways to solve it, they check their own work, they throw away the wrong paths, and then they give you the answer. This paper proves the second student, the one who thinks, beats the first one by a wide margin. In fact, their 7 billion parameter model, utilizing this search process, beat a dense 70 billion parameter model on the math benchmark. And it did it while consuming 60% less training energy. I've been watching this space for a while, and this is the moment I'd mark as the turn. The frontier has moved from who has the biggest training cluster to who has the smartest inference time search algorithm. If you're a developer or a founder, this is the story you should be paying attention to. The era of brute force pre-training is hitting a wall of diminishing returns. By moving the heavy lifting to reasoning at the moment of the request, smaller players can now compete directly with the closed source giants. It's a democratization of power, but it also means the hardware we use has to change. We no longer just need chips that can train massive nets. We need chips that can handle ultra-fast sequential reasoning loops. Now, while the researchers were proving this in the lab, OpenAI was busy shipping it to the masses. On July 9th, they launched the GPT 4.5 DeepReasoning API. This isn't just another incremental update. This model incorporates those same real-time verification loops to solve tasks that were previously too complex for a single prompt. It's scoring 92% on the graduate level Google Proof Q&A benchmark. To put that in perspective, GPT 4.0 was down at 78%. But here's what the benchmark number doesn't tell you. The real value here is the 30% reduction in technical code hallucinations. If you've ever tried to use an LLM to build a complex software architecture, you know the frustration. It looks right, it sounds right, but it fails in the corner cases. Deep reasoning is different because it evaluates its own path before it shows you a single token. It's moving us closer to autonomous agents where reliability isn't a goal, it's the baseline. My honest read, this release is a death knell for wrapper startups, those companies that just build basic workflows on top of OpenAI. If your business model was just adding a verification loop to an LLM, OpenAI just made you redundant. But if you're an enterprise developer in finance or healthcare, where a single mistake can cost millions or even lives, this is the deterministic output you've been begging for. OpenAI is setting the price at $15 per million input tokens, which tells you everything you need to know about the compute cost of thinking. It's expensive, but for high-stakes decisions, it's a bargain. Speaking of high stakes, we need to talk about what just happened in Brussels. On July 10th, The European AI Office finalized its legally binding guidelines for the EU AI Act. This is no longer a theoretical policy discussion. This is an operational survival situation. Enforcement starts in August, and the numbers involved are enough to make any CFO's blood run cold. We're talking fines of up to 35 million euros or 7% of global annual turnover, not 7% of EU revenue, global turnover. If you are using AI for biometric categorization, cognitive behavioral manipulation, or predictive policing within the EU, you have a massive target on your back. I was talking to a contact at a tier 1 US firm recently, and they've estimated their compliance cost for the second quarter of 2026 alone at $1.2 billion. That is the regulatory tax of doing business in Europe. While the EU is protecting its consumers, and there are very good reasons for these protections, we have to look at the second order effects. These compliance costs are so high that they effectively tilt the playing field toward the tech conglomerates who can afford the legal armies. I worry that mid sized firms and startups will simply be squeezed out of the European market. If you're an AI practitioner, you can't just focus on the code anymore. You have to focus on the geography of your compute. But while Europe is building walls, Meta is building bridges. Mark Zuckerberg just dropped Llama 4 Preview 8B, and it's a masterclass in edge computing. This is a model that is native in video, audio, and text. Most models see video by taking screenshots and describing them. Llama 4 processes the video stream directly. It's hitting 120 frames per second on video files. This is a massive win for the robotics industry. If you're building a drone or a warehouse robot, you don't have time to send a video frame to a cloud API and wait for a description to come back. You need split-second physical world understanding. Meta is cementing its lead in the open source world by making this kind of intelligence run on consumer-grade hardware. By bypassing the cloud, they are bypassing latency and, interestingly, some of the regulatory overhead that comes with transmitting sensitive data. It puts intense pressure on closed source vendors. Why pay for a high latency API when you can run a native multimodal model locally? Now, all of this, the thinking models, the deep reasoning, the multimodal edge, requires a very specific kind of engine. And that's where NVIDIA comes in. This week, Jensen Huang and TSMC confirmed they have successfully taped out the Rubin GPU architecture. This is the successor to Blackwell, and it's utilizing something called 12-layer high bandwidth memory, or HBM4. The headline here is a 3 times leap in compute density per watt. As someone who has spent years looking at data center efficiency, I can tell you that global power grids are buckling. We are at a point where we can build more chips than we have the electricity to power. The Rubin architecture is a critical safety valve. It allows the hyperscalers, the Googles and Microsofts of the world, to expand their capacity without having to build entirely new power plants. It's also a signal that NVIDIA's near monopoly is getting even stronger. The complexity of 12-layer HBM4 is so high that it makes it incredibly difficult for rivals to catch up. But it also means our entire industry is tethered to a very fragile supply chain in Taiwan. If that chain breaks, the AI revolution pauses. So let me connect some dots here, because I think there's a story underneath the story that most people are missing. We are witnessing the emergence of what I call the localized reasoner trend. The mainstream press is still obsessed with how big the training clusters are getting. They're looking at the 100,000 GPU builds and thinking that's where the war is won. But look at what we just discussed. We have a mathematical proof that small models can beat big ones if they think at inference time. We have OpenAI shipping that thinking as a service. We have Meta putting native sight and sound into 8 billion parameter models that run on your phone. And we have the EU making it legally and financially risky to run massive, opaque models on centralized data. The battle has shifted. It's no longer about bigger is better during training. It's about smarter is better during execution. The future belongs to compact edge models running local search loops. By shifting the compute to the client side, to your phone, your laptop, your robot, developers are bypassing the cloud, bypassing API costs, and bypassing regulatory traps. In the next 90 days, expect a wave of venture capital to flee the foundation model providers. That money is going to fund open source search wrappers and local agentic compilers. The giants are still relevant, but the center of gravity is moving to the edge. If you want to see this in action for yourself, there's one tool you should try this weekend. It's a project called Agent Zero MCTS. You can find it on GitHub. It's a lightweight terminal interface that wraps a local model like that new Llama 4 in a Monte Carlo tree search loop. When you give it a coding task, it doesn't just output code, you can actually see it thinking. It proposes a solution, simulates the outcome, finds an error, self corrects, and then executes. It gives you GPT 4.5 level reasoning accuracy directly on a MacBook without an internet connection. It satisfies that raw desire for autonomy that every developer has. No API fees, no data leaks. If you try one thing this week, let it be this. It will change your perspective on what a small model is capable of. That brings me to my viral verdict for the week. The clear winner is that RxEve paper on System 2 scaling. It's a fundamental rewrite of the economics of AI. When you decouple performance from the pre-training budget, you change who is allowed to play the game. It democratizes frontier-grade AI and shifts power away from the compute-rich oligopolies. But here is my contrarian take, and I know I'll get some pushback on this. System 2 compute is a commercial illusion for most real-time applications. We've spent a decade training users to expect instant results. If you're at a grocery store and you ask an AI a question, you are not going to wait 45 seconds for it to run a search loop to give you a perfect answer. You want a good enough answer in 500 milliseconds. The market is going to realize that thinking AI is a highly specialized tool for asynchronous agents, the kind of things that work while you sleep. The hype around search-based LLMs replacing our standard chat interfaces is going to face a very harsh reality check when it hits the wall of human impatience. We're moving from the era of the fast guesser to the era of the slow thinker. And as I wrote in my book, Making Money Out of Data, value isn't found in the quantity of the output, but in the reliability of the insight. This week, the industry finally realized that thinking is the most valuable feature of all. If something in today's episode sparked a thought, or if you think I'm wrong about the latency issue, I genuinely want to hear it. This is a conversation, not a lecture. Find me on LinkedIn or Twitter, or drop a comment on the Medium post for this episode. If you found this valuable, share it with one person who needs to know where the industry is heading. That's how this community stays ahead. Next week, we're going to look at something that's been quietly building for 18 months in the background of everything we talked about today. It's a shift in how AI models are being taught to handle physical space, and it's going to reframe how you think about the labor market. You won't want to miss that one. Until then, stay curious, stay ahead. This is Shaylee signing off.